All right, guys, so today is April 6th, and we are back in school, starting some new material. For those of you that were there the last day, we posted a lot of this stuff into our notebooks. Um, I'm going to try to go over, so we're starting new content. So this unit is called Solutions. So we're going to be looking at um, types of solutions, okay, and what they are, the components of them, how to calculate concentration, like for instance, how much of this is in that, how do we measure that? So I put this little chart there at the top. This is actually something we learned way back, I think, the first 9 weeks. So this is kind of old stuff, this little chart here, you have had it before. Um, and so when we have matter, we can separate matter into different subcategories. Um, so with matter, right here, matter, okay, we have substances and we have mixtures, okay? Now, the substances, or pure substances, that's kind of what we called them before. The pure substances can break down into compounds or elements. And compounds and elements, those are things that if you look on the periodic table, that's what they are. So if I look on the periodic table and I have Na, that is sodium, right? A compound would be NaCl. Okay, so those are the things that you see on the periodic table. That's a pure substance, okay? It cannot be broken down unless you had a chemical reaction. Mixtures, on the other hand, those are if we have two or more pure substances, okay? And if you recall, we broke those into two little categories there. We had homogeneous mixtures and we had heterogeneous mixtures. Heterogeneous is ones that you can kind of see the different parts. So like Rocky Road ice cream, rocks in dirt, you can pick out parts and pieces. Homogeneous is when everything is evenly distributed. Okay? All right. So with homogeneous mixture, we can't really see the different parts. For instance, if I have salt water, okay, can I see the salt and can I see the water? No, it mixes together. It makes a homogeneous mixture. Okay, everything's evenly distributed. And it would take some type of, by the way, you may hear my dogs at some point, but sorry about that. For homogeneous mixtures, you've got to do some type of separation technique, okay, to get those guys. And it would be a physical separation, okay? And we'll go over that a little bit later. So when I have a homogeneous mixtures, you need to get these little terms straight here, okay? Oops, it's not going to work the way I wanted it to. All right, so what we have here is we have the solute, okay? And so if I had salt water, the solute would be the salt. If I had a solvent, that would be my water. Okay, so those are my two parts. Okay, now the solution, that is where I have the salt plus the water. That's those two things combined. Okay, now here's a little example down here. Okay, and this kind of shows you the same type of thing where we did the salt and the water, but this would be sugar water. So I have my sugar is my solute, my water is my solvent, and once it's dissolved, my solution is the sugar dissolved in the water. Okay, hopefully that makes sense. And so the thing is, though, usually when you guys think about a solvent, most of the time it's going to be water, but it doesn't have to be. Okay, and in fact, we can actually have, this is kind of crazy, we can have a solid solute and a solid solvent. Okay, that sounds kind of weird. So I'm going to go over these because it depends on the phase, so whether it's a solid, liquid, or gas of the solute, and then the phase, solid, liquid, gas of the solvent. Okay, so let's try this. And I apologize because I am trying some new things with connecting my iPad here so you guys can actually see things a little bit better. Okay. All right. So if I go down here and I see this, the phase of the solute, so you can see this little chart, and I'm going to change colors for a second since it's got green on it. So here is the phase, the chart. So you can see I have the phase of the solute, the phase of the solvent, and I think I'm going to have to erase on here as well. Oops, did not mean to do that. So stay with me, guys. I'm kind of new to doing this with my iPad. So let me get my eraser. Okay, and I'm going to erase some of this here so that you guys can see what I'm doing. All right. Okay. And then I have the phase of the actual solution. So this is the part one, the part two, and then this is the whole. All right. And then here's some examples here just so you can sort of understand what that is. So the phase of the solute, if the solute is a solid and the solvent is a solid, and this is kind of rare, okay? This is kind of weird to think about. That is an example of that is our metal alloys. Now, what do we have to do when we actually mix those guys? They have to be a liquid, right? You melt the metal, you mix it together. But at room temperature, the solution is a solid. And what you're going to find is the phase of the solution is the same as the phase of the solvent. Okay, so I'll give you some examples here. So if I have a phase of the solute is a solid and a liquid. So this is the same as our sugar and our water, right? All right, and so example of that would be Kool-Aid, but you notice the overall phase is still a liquid. Okay, now if I have a liquid and a liquid, all right, so we're talking about, for instance, right now the big thing is alcohol, isopropyl alcohol, i.e. rubbing alcohol. Don't get that confused. If you look on the bottle, and this is the big thing right now, is it needs to say 70% alcohol. Okay, so 70% of rubbing alcohol is isopropanol. Okay, that's an alcohol. I don't know if you guys remember. We'll do a little side note here. My organic. So that would be propanol. So prop means 3 carbons. And then it would be C5OH. I don't know if you guys remember that. That's propanol right there. But propanol is a liquid. And then they mix it with water. And water is a liquid as well. And so then the final thing I get is, again, a liquid. Okay, so there's ethanol. You can use propanol. You can use ethanol. Gasoline is actually a great example because gasoline has a lot of different stuff in it. So some of it's liquids, and you dissolve that into, if you recall, octane. You'll see on your, if you go to get gas, I don't know how many of you are driving, but it might say like 89% octane. And that means the majority of it is octane. Ooh, who remembers this formula? Octane means 8, and then H, 18. Just a little organic review there. All right, now what about if my phase of the solute is a gas, and it can be, and then my solvent is a liquid? So that's any soda. Any soda. We take carbon dioxide gas, take that CO2 there, and we dissolve it in liquid, mainly water, and then we get that dissolved carbon dioxide. And so that's actually a solution. Now, we can also have gas and a gas. That's just air, right? I don't have a chunk of oxygen sitting in one corner and a chunk of carbon dioxide in the other. Gases, if you recall from the gas unit, they always equally distribute amongst themselves. So that's going to be an example as well. All right. hopefully, if you've got any questions, pause me, write them down, and then you can put them into Schoology under questions. Okay? All right. So, what is concentration? So, just like we just talked about, that 70% isopropanol. Okay? And that's our rubbing alcohol. Okay? All right. So, that's our rubbing alcohol there. 70%. So that means we have 70%, right, alcohol and 30% water, right? Okay. So that's pretty easy, standard, right? But in chemistry, there's a lot of ways that we need to measure concentration a little bit differently. Okay? And so when we do concentration, what we're looking at is how much solute, so that would be like your salt, do we have in a solvent? All right, so if you had salt water, oops, it would be how much salt is in the water. Okay, so this is probably the two most common. If you look here, and it is molarity, which is represented by a big or capital M, and molality, which is represented by a little m. Now, normally I would go ahead and teach molality, but it's not used in AP chemistry. And in all honesty, when I was in industry, I don't think I ever used molality before. So, we're kind of cutting down to the bare minimum. So we're going to go over molarity. That's the one you're going to use the most, especially in AP. We use it quite a bit. So let's see if I can scroll that down for you. All right, so what is it? So we're going to be looking at moles. Oh, don't we love moles? Yes. Remember moles? Avogadro's number? You're going to have to remember how to calculate moles. All right? Per liters of the solution. Okay? So what we're looking at is if I have my, you guys know how well I can do, if I have my salt and my water there, how much salt do I have in this much water? Okay? Or this much salt water, rather, sorry, it's solution. You have to be really careful and say, okay, it's this much. Now, with molarity, here is the formula right here. The mole of the solute divided by liters of solution. Now, the thing you've really got to be careful, I'm telling you right now, is it has to be in liters. So if you get milliliters, you've got to convert to liters. Don't forget about that. So I'm going to write a little note down here to remind you. 1,000 milliliters is in 1 liter. So we're going to have to go back and use things that we learned in the past to do some of these calculations. Okay. Now, I'm going to tell you what molality is, but we're not really going to go over it too much. And I am going to do this. Let's see. Molality. Okay. Again, this is sort of new using my iPad with my computer to do this. So let's see if I can erase this stuff that's on here. Okay. Unfortunately, sometimes my iPad is not showing what is on my computer screen, which is what you guys are seeing. So I kind of have to erase on everything. So let's see. I'm sorry. Again, terribly sorry. All right. So molality, let me get the eraser here. I am going to tell you what it is in case you see it later in life. If you take chemistry in college, you might see it. I can honestly say I don't remember. That was way too long ago for me. All right, molality, you notice there's an L there. Sorry, I didn't mean to move it, okay? And that's a way of measuring concentration as well. But if you look at the units here, okay, it's still moles of solute, but it's kilograms of solvent. Where, let's see if we can go back down. Whereas molarity is moles of solute, liter of solution. So they are, they're a little bit different. So we do need to know that there is a difference. But what we're going to be doing in this class is we're going to be looking at molarity. Okay? All right. And molarity is represented by a big M. Okay? So I'm going to scroll this down a little bit. All right. So molarity its symbol is a capital M. Okay? And I'm sorry you didn't see that very well. Molarity is a capital M, so don't forget that. Okay? All right. So we can calculate molarity, and you could do molality, okay, using the above equations. So I want you to look at this example here. So this is molarity. This is the only one we're going to be doing this year. So what I want to do is I want to find out if I'm in the lab and I need to make this. And whenever I make you guys reagents, this is what I have to do. Okay. If I have 26.2 grams, okay, of sodium chloride, and I dilute it to 100 mils. Okay. So 100 mils is my solution. That's how much solution I have. The NaCl, and my dog might bark in a minute, sorry, is my solute. Okay? So if you remember, molarity, let's see if I can write it up here, big M is mole over liter. So I've got grams. Well, we know how to do grams per mole. How do I do grams per mole? I have to get that molar mass, right? And so for NaCl, let's see if this will work. For NaCl, I have to add up the Na plus the Cl. And I do have a periodic table somewhere in my desk. Somewhere. That's one thing I forgot. So we're going to add up the NaCl, which, if I recall, is 22.99. And then chlorine, I think, is 35.45. I do believe. So I think it's 58.44 yeah, there we go, 58.44. Perfect. Okay. So I've got to get that molar mass, and I am going to convert it to moles. Once I have moles of the solute, okay, that's what I'm going to plug in for this guy right here. Okay, so I had to get that moles. Now remember, I need liters, but my question gave me milliliters. So I'm going to have to convert that. So I have my 100 mils. Excuse me. Throat's getting dry. And I need to do that conversion. Remember, this is our conversion from milliliter to liter. And I get 0.1 liters. Now, you're going to notice here I'm doing sig figs. Okay, don't forget your sig figs. Once I get the mole and once I get the liter, all I do is plug in to the mole divided by the liter. Okay, so if you have your calculator, okay, and you did this, you would get 4.48 mole over liter. Now that mole over liter, I can replace with a capital M. Okay? I'll let some of you catch up if you are doing so. The molality example is below. If you want to look at it, feel free. Like I said, it's not erasing. Oh, that's going to work actually. Great. Okay. So the molality example there, you can do yourself. I'm not going to go into it too much because, again, you're not going to be responsible for knowing that information. Okay. All right. Let's go to the next page. All right. Here's some molarity practice problems. Okay. What is the concentration if I have 58 grams in 1 liter? All right, now it gave me grams. Remember, Big M is mole, and there's my dog, mole over liter. Shh. Hush. Sorry, y'all are going to get that quite a bit next couple weeks. All right, mole. I don't have moles though. What do I have? I've got grams. I've got to get that grams into moles. Okay, so I need to get 58 grams, but I need to get it into moles. So I'm using my molar mass. So I'm going to do my 58 grams of NaCl, okay, times 1 mole of NaCl, and we actually already got that molar mass. So remember, Na plus Cl is about 58. Oops, and I have no idea how that happened. It's kind of like class time, isn't it, guys? All right, or normal class time. All right, so that's 58 grams approximately. And 58 divided 50 is 1. How many sig figs? Ooh, looks like 2. So I have 1.0 mole. Okay, so now big M equals mole over liter. So the moles that I calculated in the upper right, 1.0 mole. And you notice it already gave it to me in liter. That's great. That means I don't have to convert. So 1.0 liter. 1 divided by 1 is 1. Keep your correct number of significant figures. And I get 1.0 mole over liter, which is 1.0 big M. Okay, not too bad. All right. Unfortunately, sometimes it erases on my iPad, but it doesn't erase on here, so I'm sorry about that line there. All right, let's look at number 2. What is the concentration if I have 10 grams of silver nitrate in 500 mils? Silver nitrate. Shh. So we've got to add up, right? We've got to add up a silver. We've got to add up a nitrate. And I've got to add up 3 oxygens. Okay? So I'm going to get my calculator. You guys get your calculator too. Okay? All right. So let's look at this. So silver. I wonder if I can do this. I wonder if it'll still record. Let's try it. I'm going to try to go to a periodic table. How does that sound? All right. Hoping it'll still record. All right. Because this way, if you guys don't have your periodic table, you can pull one up online, just like what I'm doing. Okay, I'm trying to find one that's similar to what we use in class. There we go. There's one. Hopefully that's right. Let's see. Okay, cool. All right, so I'm going to scroll this down so you guys can see the periodic table. Okay, so let's see. Sodium's 2299. So we're going to type that in. So we have 1 sodium, 22.99, plus 1 nitrogen, which is 14.01. And I'm sorry, it's not sodium nitrate, it's silver nitrate. God, y'all feel like y'all are actually back in class with me. Silver, I'm sorry, not sodium. Silver is 107.87. And then we're going to add up a nitrogen, so 14.01. And then we've got 3 oxygens there. So 3 times 16 is 48. Okay? So I go back. Let me pull up the notes here. Okay. All right. So here we go. I got 169.88 was my mass. So the first thing I need to do is I need to get that gram, and I need to get it to moles. So I'm going to divide by the molar mass, which I got 169.88. If for some reason I'm doing this wrong, just put the right number in. You guys know I like to screw up sometimes. All right, so 10 divided by the 169.88, and I get 0.05. Let's see, how many sig figs do I have? I got 3. So 0.05 0.0589 mole. Okay. Now what it wants me to do is I've got 500 milliliters. Oh dear, I got to get that to liters, don't I? Okay, so do that conversion down here. 500 milliliters. Sorry, it's kind of shrinking down here. 1,000 milliliters are in 1 liter. So I have 0.500 liters. Okay, now I'm going to plug this in. Big M equals, molarity is mole over liter. Okay, so the moles is 0.0589. The liters is 0.500. Okay, and let's add that up. So divided by, so 0.0589 divided by 0.5. Okay, I get 0.1178. And if I do sig figs, 3 sig figs, it should be 0.118 big M. Okay, so it's not too bad. Now, the next question we're going to go to, because you can rearrange this equation, right? So sometimes they're going to give you the molarity, and they're going to want you to figure out how much mass you need. And that's actually something I do when I'm making reagents. A recipe kind of tells you what you need, but I need to figure out how to make it. Okay? So let's see if I can, this works. I'm not sure if it'll work or not on the screen above. And it's probably not. And that's okay. We're winging it, guys, right? Okay. So let me scroll this up, and then what I'm going to have to do below is I'm going to have to erase what's on my screen, okay? Okay. I'm going to go back up, and so what I'm going to need to do is scroll it up. All right, let's look at number 3. That's what we're going to be looking at here, okay? And I'm going to erase what's on the screen. Okay. And I'm trying to keep these videos to 30 minutes, but whenever we go over something new, it's a little bit hard because I want you to kind of see everything, right? All right, so let's look at number 3. Okay, what mass? Okay, this time it's asking for mass. Okay, what mass of potassium nitrate to get 2 liters of a 0.500 big M? Okay, so this time they're giving me molarity, but I need to get the mass. Okay, so if you remember, big M equals mole over liter, right? So this time I have big M, 0.500, big M. What I need is I need the moles, right? And I have 2.00 liters. So what I'm going to do this time is I'm going to solve for mole, and then you're going to do your regular conversion from moles to grams to actually get the mass, because remember, mass is grams. Okay, so that means I'd multiply both sides by 2. Let's get your little calculator out here. So I'm going to have 0.5 times 2.00, and I would get 1.00 moles, and that's with significant figures, okay? All right, so, but it wants grams, right? It wants mass. So now I'm going to have to convert. We can go from moles to mass, right? All right, so here we go. We're going to use the molar mass. Okay, so 1.00 mole. Now, how many grams are in 1 mole of potassium nitrate? So we're going to have to add up the K, the N, and 3 O's. Okay, so let's go see if I can get us back to our periodic table. Okay. All right, so where is Mr. Potassium? He's over here. So 39.1. I'm just kind of rounding these. So 39.1 plus a nitrogen, which is 14-ish. And then 3 oxygens, which we just found out was 48, right? All right. And so I get 101.11 grams. So 101.11 grams is in 1 mole. Okay, now it just so happens that that's an easy fix, right? So how many grams would I need? I would need 101 grams of potassium nitrate. Okay, see how you can kind of rearrange the equation to be what you want it is. And I forgot to pop that back up. So let me get back to this. Okay. All right. So this up here, this is what I just did. Okay. This little section right there. Okay. All right. And the last example I want to go over is actually number 4, because this way I'm giving you examples of any of them being the unknowns. Okay, so I'm going to erase this. Okay. All right, and I'm going to erase it on y'all's screen. I wish it would do both on my iPad and on the screen, but it doesn't, and that's okay. We can make do, right? Okay, so here we go. We're going to try number 4. Okay. All right, number 4 there. All right, so let me get my pen back on. All right, what volume, if you have 5 grams of KCl, in order to prepare, ooh, look at that big M. That means they gave me molarity because that big M is there. So let's go back over. So big M is mole over liter, right? So big M is 0.25, okay? Mole, oh, we don't have moles, but what do we have? We have grams, okay? So that means we can get moles. And then the liters, what's asking me what volume? So that liter is what I'm going to be solving for. But first I got to get that mole up there. So I'm going to come down in the space where number 5 is, okay? 5.0 grams, because we need to get this to moles. 1 mole. We're going to erase this question here, okay? We've got KCl, so let's go back to our periodic table. All right, K, here it is, 3910. So the K is 3910. The Cl is 3545. Okay, I'm going to add those little guys together there, 39.1 plus 3545. And we get a total K plus the Cl is 74.55 grams. Okay, so I'm going to go up here. I'm going to put that in to get my moles. Okay, all right, so I need to solve for moles. So that would equal, let's see, 5 divided by 74.55. All right, and so I get 0.06. So I got 2 sig figs, 6.7 moles. Now that I've got moles, I'm going to go back up here. Oh, poop. Sorry. Here's what I just did right here. All right. I forget to go back and forth. All right. This is what I just did right here. Okay. That's what I just did. Okay. So when I calculated that out, so I'm going to go back up to here now and plug that in. So 0.067 moles. Now I've got to solve for something in the denominator, right? Okay, so when you do that and you rearrange it, hopefully everybody's algebra is okay at this point. I'm going to have 0.067 divided by 0.25. All right, all I'm doing is solving for the unknown. So 0.067 divided by 0.25, and I get 0.268. So 0.268 liters. Now I should only have 2 sig figs, so 0.27 liters. Okay, so what I've shown you is the 3 different scenarios you could get for one of these problems. Okay, all right, let's go back here. Okay. All right. This next worksheet is molality. We're not going to do that. All I care about at this point is molarity. Okay. Now, if you have questions, please, put questions on Schoology, where we have that kind of update, because if you have a question, there's probably 20 other kids that have the same question. Okay. All right. So you will also have a check, understanding check, which will be in Schoology as well. It'll be under classwork. Okay. And it's going to be like a little worksheet that you're going to do, turn in. I'll give you feedback. Okay. All right, guys, that's lesson for today, April 6th. And also check the YouTube channel. I'll try to put this on there, as well as just kind of personal updates too. All right, guys, bye.